We're going to start on this Pokemon workshop. So this will be interactive. So I will send a link in the chat of the notebook we're going to use. So it should be sent. And I will show you the entire workshop as we go along. All right. So welcome to the PokéGraph course workshop. Here we're going to show you how to create your own Pokemon graph with TigerGraph. So you'll create your very own TigerGraph solution. You'll create your graph by creating a schema. You'll upload data into your schema. And then we're going to create some cool UIs, and you'll also learn a little bit about querying. So it'll be the full deal here. All right. So we're going to start off with a sneak peek. So welcome to the workshop. What the data we're going to be using is going to be Pokemon data. So it'll be from the PokéAPI. So here's a little bit about it, and then we can go to the actual API, looking at Pokemon, and we're going to grab directly from this Pokemon endpoint to grab different information about Pokemon, like their abilities, their forms, their game indices, held items, moves, species, sprites, stats, types, and so on. So here's a little preview of the data. I'm going to restart my runtime. Yes. Great. So a little bit about Colab is that this is both going to have some text and some code. So you'll be able to follow along like through the code. And then if you ever miss something or if you're ever confused, there's also a bunch of text explaining out each section. And so to play a thing on Colab, you can use the arrows to toggle different sections. To play something, you can either press this play button, or you can do Control or Command Enter, and that'll automatically play it. So here, I'm just going to start off by importing two libraries. First is JSON. That'll just format everything nicely when we print it out. And second will be requests. Requests is going to be how we're going to do get requests, which is going to be how we're going to grab data from our API. All right. Let's go. So this is a bit of the data that we'll be able to see. This, once again, queries the Pokemon endpoint. And then we're looking at ID 12. So ID 12, I just so happen to know that it is Butterfree, and it's also shown right here. Then you have a bunch of different data about it. So like you have the moves information, you have different information about leveling, and so on. And then we're also going to be looking at specific things from it, like we're going to look at the species names. So in this case, it's Butterfree. We'll also look at the different types that it's connected to. So Butterfree is both a flying Pokemon, it's also a bug Pokemon. Then you'll also see us working on other things, like we're going to create a linear regression using the data we have. And we'll also create a dashboard near the end. So let's get to it. The first thing you're going to need to do is that you're going to need to create an account on tgcloud.io. So to do this, you're going to go here and click login/register. And then I automatically get logged in because I've been here before, but you might need to create an account on Google or log in with Google or just log in with your email. There's also an option to log in with LinkedIn, but I'm assuming most of you don't have LinkedIn quite yet. So I'll give you a few minutes to start logging in. And in the meantime, we're going to next have to go through what exactly is TigerGraph and then what is graph. So go ahead and log in, create your account, and then we'll go ahead and jump into setting up TigerGraph box. And I can, thank you. So as we wait, I'm going to go over what exactly is graph. So graph databases are almost everywhere. Whoa. But here is a slide with a few different types of graph database or different database types. So a few include relational databases, key value databases, and graph databases. Now, here are some of the benefits and drawbacks of each type of database. A relational database has a rigid schema, and it's good for transactions, but it has poor performance for deep analytics. Key value databases, they have fluid schemas, and they're good for simple transactions, but also they can't perform deep analytics. But with a graph, you can have both a flexible schema, and you can have high performance for complex transactions and deep analytics. All right, so I'm going to go back and we'll start working on setting up our TigerGraph box. All right, so once you're in TigerGraph and you log in, you'll be able to see a dashboard like this. Of course, you probably won't have as much things. It won't be as populated as mine. But next, we're going to go to My Solution. So here in this sidebar, you have Dashboard, which is all the overview. My Solution is where we're going to create a solution, and using that solution, we'll add graphs to it. So this should be empty. We'll start off with Create Solution. Now here, we're going to keep it at the normal version. We won't mess with that. And then we're also going to select blank. Now, there are a bunch of different starter kits offered by TigerGraph. We're not going to use them since we're loading our own data, which will be the Pokemon data. But you can see that there's a bunch of different uses for graphs, such as COVID-19 example. There are some fraud detections, there are healthcare graphs, and so on. So there's really a wide variety of places where you can use graph. But right now, we're just going to use a Pokemon example for fun. So press next, and then on the second page, don't click anything. You don't have to worry about this. This is in essence just saying that we're going to start up a free tier for TigerGraph. Now, here in Solution Settings, you're going to need to name your solution, tag your solution, set a subdomain, a description, and also set a password. So I'm going to keep it pretty simple. Our solution name will be Pokemon. Our tag will be Pokemon. Now, the default initial password for TigerGraph is TigerGraph. I'm going to leave it as is for the purpose of this lesson. Now, in subdomain, every subdomain has to be unique. So my default subdomain I'd put as Pokemon. But since I'm using the Pokemon subdomain, you all can't use that. So you'd want to probably put your first name. I'd recommend first name dash Pokemon, or if you want to do first name, last name dash Pokemon, or just create something very different. But for all purposes of this lesson, I'm going to just name it subdomain or Pokemon. Finally, in description, I'm just going to put Pokemon once again. Then hit next, and this is what you should see. So you'll have the version is 3.1.1, starter kit will be blank, and then make sure you have a unique subdomain. You will have to remember your subdomain. Also, do keep note of your password as well. If you didn't change it like I did, then it should just be TigerGraph. And then finally, you're going to click Submit. Now you'll be able to see that it is a pending task. You won't have much of other tasks around here, but you'll see Pokemon there, and then it'll have initializing solution, ETA 1 minute, and you'll know that it's ready once this is green. Okay, I'm going to stop there for a minute. All the instructions are right here. You can kind of see selecting the blank, not changing anything here, updating the parameters here. So if you did get lost through that, you can always check back there, just making sure that everyone is good. If you have a question, just let me know in the chat. And as we kind of wait, we're going to go back to what are graph databases. So graph databases, as you saw here, they're really good for deep analytics. Now, something that you might be confused about is that graph databases, graph, isn't necessarily what you use at school. So I touched on this a bit during my keynote. In school, you hear about graphs like bar graphs, like line graphs. No, these graphs are the cooler graphs. You have here, you can sort of see that there are a bunch of vertices. So here a vertex would be payment, a vertex would be order, and they're connected with different edges. So here you have the accepted edge. The example I used in the keynote, and it is one of my favorite examples, would be that game where you start on one Wikipedia page and you try to get to another Wikipedia page as fast as possible. Now in that, you'd have a vertex, which would be an article, and then you'd have an edge, which is linked to or like connected to another thing, another article. And so you can use that, you can see all of its connections, and you'll be able to very quickly find like a shortest path to find what's the quickest way to get from this first article to the second article. And another example is in TikTok or in other social media pages. So in TikTok, everything, once again, is like connected to each other. You can start off with TikTok that you're watching, then you can click the songs, and that will be a one-hop query. So you're starting from your TikTok, going to the songs, and you'll see, okay, how many other TikToks use this song. Then you can go from there to a person's profile. Okay, this person, what TikToks have they created? You can also see sort of how similar people are or what connects people. So one TikTok person, one user, could be connected to a certain song, and the other user could have also been connected to that certain song. So there is that, and it could be possibly used as something like a recommendation system, and so on. So really, graph databases are kind of under everything. It's really amazing to me. And this is still processing. Let's see. It might take a few more minutes for this to start loading up. In the meantime, we are going to, once again, just look through the data that we will be using. So in this data, we're going to be focusing on loading a few primary things. So we're going to start off by looking at the different species names. So Butterfree, so Pikachu, and so on. Then we're also going to be looking at the types. So if I were to print for I in res types, print I apposition type name. So here, as I sort of mentioned before, there are two types. There will be both bug and flying. And so in that case, Butterfree would be connected to both the vertex bug and the vertex flying. So we'll have the two. In addition, we're going to also be loading moves. And then the moves vertex, or vertex that will be with moves, will include a bunch of different ones, such as Razor Wind, and Red Blue, and so on. So this moves vertex will be what we'll do when we create a more complex schema. And then if you do want to explore adding even more data, creating even more complex schema, there will be a course coming out that I'm developing on Udemy, and there will also include other data such as location of the Pokemon, location areas, carried items, and so on. Okay. So we will continue to wait for the solution to start up. It's still processing at the moment. And then we can go ahead and jump into creating the Pokemon graph. So before we start this connection, here are the libraries which we're going to be using. We're going to be using requests, which once again, as I mentioned before, is going to be how we're going to create GET requests and how we're going to create post, really just the GET request to grab data from this Pokemon endpoint. Next, we're going to be using JSON. So JSON is just going to be how we're going to print it out nicely. It's not necessarily required, but it's going to be how we can look at our data more easily. Then finally, we're going to be using pyTigerGraph. The documentation for pyTigerGraph is right here. And pyTigerGraph is a Python library, which is going to be how we're going to interact with our TigerGraph solution. So with pyTigerGraph, we're going to be able to upsert all our vertices, we're going to be able to upsert edges, we're going to be able to run queries, and so on. Right, now that our solution is ready, let's first just run and install pyTigerGraph. Then we're going to import all of our required libraries. Then we're going to set up connection details. So this is what you set when you created your solution. The host will be, for me, Pokemon. What I recommended you all to do is doing your first name dash Pokemon, or your first name dash last name dash Pokemon. And if you forgot your domain name, it'll be right here. So you'll want to go ahead and click Applications, then press Graph Studio, and then you'll be taken here. This is a user interface, which makes it kind of nice to be able to design schemas, and you can have a no-code solution this way, but we're going to be using Python to explore the code. So first you'll have that. So yours won't be Pokemon, it might be something similar, but it's whatever you set in the first step. Next, you're going to set the password. Now, if you kept the default password, like I suggested, you'd be using TigerGraph. Then the rest you don't have to worry about, it's just a SQL number, and that we are going to be using a certificate. And then running that, we're all set. If this for whatever reason doesn't load or takes a while to load, that could possibly mean that your status here isn't green. So do check that out, just in case. All right, so the first thing we're going to do is we're going to create our schema. This is just an ls, so if we were to run it, it'll show that there is nothing really in our graph yet. Just running that, we have no vertices, we have no edges, no graphs, no jobs, nothing. It's empty. We just created it. But for the create edges, we're going to start our first ever graph, our first schema. So how will we model the data we have? First, we'll create Pokemon. So the Pokemon will just be any Pokemon, like Butterfree. Then we'll set primary ID, name, string. What this means, think of a primary ID as a unique identifier for each Pokemon. In this case, it'd just be the name. So every Pokemon is named something different. There's only one Butterfree, there's only one Pikachu, I guess, type Pokemon. And then we're calling that variable, that unique ID, that primary ID, name, and the type is string. So a string is just a text. Then what we have here is with primary ID as attribute equals true. So what this is saying is that our primary ID is going to be an attribute. So name will be an attribute. What an attribute is for our purposes, is what we can use later on when we're starting to write queries. We'll be able to access whatever the primary ID is. So we'll be able to access the name of the Pokemon. We'll do the same thing here for type. So create vertex type. Now we're creating a vertex, and the type of the vertex will be a type. Then we'll have the primary ID, type ID, as a string. So our primary ID, our unique identifier, will be the type ID. So what this is, it'll just also be the name of the type. So it could be a fire type, it could be a flying type, it could be a bug type. And once again, the type of variable this will be is going to be a string. And finally, we're also going to say that the primary ID will be an attribute, so we can access the name of the type when we do it. Finally, we're going to create an undirected edge Pokemon type from Pokemon to type. Let's break this down. So an edge is going to be what's going to connect the two vertices, how the two vertices relate to each other. Now there are two different types of edges. There's a directed edge and there's an undirected edge. Directed edge means that we're going to go from one place to another place. So we can only go from Pokemon to type, but we can't go from type to Pokemon. That's with a directed edge. An undirected edge is the opposite of this. So we can go from Pokemon to type. We can also go from type to Pokemon. The direction we're going doesn't matter. So for us, it's not like only a Pokemon can point to a type. We can go both ways. And that's what we're going to do. Let's run that. And then we've created this. Now we're going to create the graph. It's pretty simple syntax, create graph. Then here is going to be the name of the graph. So the name of the graph, in our case, is just Pokemon graph. Then finally, you're going to have the vertices and edges associated with it. So we're going to add the Pokemon vertex, we're going to add the type vertex, we're going to add this Pokemon type edge that we created. Run that. And it might take a little bit for it to load up, but as soon as it does, we'll be able to see this in Graph Studio. So right now there's no graphs, but after that runs, we'll be able to see graphs, which will be pretty cool. So we'll give it a few minutes for it to run, or it should be a few seconds. Probably the parts which will take the longest time will be adding things to Graph Studio. So it'll be loading up this graph. It'll be creating schema change jobs. It'll be creating the queries. And then once we have it uploaded, then everything will be a lot faster. So nice. We were able to create it up. And then if we refresh this page, go here, you should be able to see Pokemon Graph. If you don't, you might have had a problem with the connection. Then we can go here to Design Schema and wait for it to load. And here is the schema that we created. So here we have the Pokemon vertex, and here we have the primary ID, which is string. We have the type, which primary ID is type ID and also string. And then we have the Pokemon type edge connecting it. Now you could have attributes on the Pokemon type edge, sort of like how you see things underneath here, but we didn't add that yet. And in this lesson, we won't be adding attributes to edges. Next, we're going to update our connection parameters. So we're going to change two things. First, we're going to say which graph are we using, the graph name. This is Pokemon Graph, what we created up here. Next, we're going to create an API token. Now, pyTigerGraph can handle this for us by creating a secret and then running a get token function. And all this does is it's going to let us load data into our graph. All right, nice. So I'm going to stop here, just making sure everyone is good for now. Oh, okay. So if you're good with the create solution, just let me know. Is creating a solution good for you right now? And if you want it, we can wait for a little bit as you set it up, or I could just keep on going forward. So I think John got it covered for you, so that's good. I'm going to continue walking through. If you have any questions, though, feel free to stop me, and I'll kind of check after each section. Okay, now we're going to load data into our Pokemon graph. So the URL here is the exact same that we did in the preview. So it's this endpoint. And then we already sort of walked through it. So I'm just going to run it, and it'll be the exact same thing we did last time, or above. And it's just the species name and then types. You can kind of see that. Now we're going to upsert one vertex. So the first vertex we're going to do is we're going to upsert a Pokemon vertex. We'll use the request that we created here. So here we have all the data for the Butterfree vertex. And here are the parameters. First, we're going to say which vertex are we upserting. The vertex we're upserting here is going to be the Pokemon vertex. So it'll be this one. We're going to add one Pokemon vertex into our graph. Next, we're going to say, okay, what's the primary ID of the Pokemon vertex? What's its name, unique name? We're going to grab the species name. So right here, that's Butterfree. Then lastly, we're going to add attributes. So the attributes that we're going to have is going to be name, because remember way back when we said that the primary ID is going to be an attribute? Well, here it is. The attribute's name. And then what is the attribute? It's going to be the species name. So it's going to be Butterfree. You can go ahead and run that. And then if you go back here to your Graph Studio, click Load Data, we'll see that now we have a singular vertex in our graph. And the type of vertex is going to be Pokemon. So we have one thing in our graph. Huzzah. Next, we're going to upsert the types. So once again, we're doing upsert vertex. the type of the vertex we're going to upsert is type. Then the unique name for our type, the primary ID, is going to be type name. So the first one will be bug. The second one will be flying. And then our attributes, once again, we have that type ID, which we said is also the primary ID, but it will also be an attribute. And it's the same exact thing, type name. Finally, we're going to upsert an edge. So this edge will be able to connect our Pokemon vertex to our type vertex. And here's the syntax. Okay, so which vertex should we start on? We're going to start on a Pokemon type vertex, or a Pokemon vertex. Then we're going to upsert, or we're going to connect which Pokemon vertex? We're going to connect the Butterfree Pokemon vertex. We're starting off on the Pokemon vertex called Butterfree. Then we'll connect it using the Pokemon type edge. Okay, now where are we going to? We're going to connect it to the type vertex. And which type vertex? Well, first we're going to connect it to the bug vertex. And next we're going to connect it to the flying vertex. So I will run it right here. And we go to load data. Now you'll be able to see that we have three vertices in our graph. Three vertices will be our Butterfree, flying, and bug. We have two edges, so one will be connecting flying to Butterfree, the other will be connecting bug to Butterfree. We have one Pokemon, which is Butterfree, our two types, flying and bug, and finally our Pokemon type edge. You can also see it right here. So this is Explore Graph. You can go to here and click all. We don't have 5 of each, but here are our vertices that we have upserted. If you go to Butterfree and you double click it, you'll see all the edges connected to Butterfree. And so here is our entire graph as of now. We have Butterfree connected to bug and flying. Now we're going to load more vertices and edges. So we'll load 9 because the range is not including the 10. And what it'll do is exactly what we've been doing. It's going to create a GET request to this Pokemon endpoint. This time it'll be at different Pokemon, so based on the ID. Then we're going to upsert vertices to our graph. We'll start off upserting the Pokemon vertex. Then we're going to upsert type vertices and then edge vertices. Then it's just going to say, yeah, we added it. So let's run that. Right, we added Bulbasaur, Ivysaur, Venusaur, Charmander, Charmeleon, Charizard, Squirtle, Wordle, and Blastoise. Okay, so now if we go to load data, now we have a lot more. We have 16 vertices, and we have 15 edges. And so to clear all of this, you can double click this, or just single click the hide button. And now let's pick out just Pokemon. Pick out 5 Pokemon. And then if you double click it, okay, Wordle is a water type. Double click water type. And Blastoise is also a water type. And so is Squirtle. And then we can continue like double clicking. What else is Squirtle? Squirtle's just a water type. Blast is just a water type. Venusaur is both a poison and a grass type. And you can keep on exploring it. So let's load all the data. Now, calling it from an API is good, but it takes a while for it to call. So I put all of this data into a CSV called initial upsert, and we can go ahead and run that. This is what it looks like, the CSV. It's just the name and the type. And then we can run this, which will just upsert this data frame into the different edges and vertices. So here we now have that many vertices upserted. And then if we clear it out, you can check the load data. Yeah, now we have 916 vertices and 1,340 edges. Explore the graph. Let's look at a few, and we can kind of, once again, just go through each one. Okay, this is water type. And now water type should have a bunch of Pokemon. Now, if you click on something which has a bunch, you can just press this undo button right here, and then it'll close it out. Now, in Graph Studio, there's some cool things that we can do. In the beginning, I always mention like finding paths between two things. Here in Graph Studio, it'll let you do that. So you can go to this Find Path section, and we can start off with 2 random Pokemon. Let's search. Okay. Let me grab 2 Pokemon from here. So we have Venusaur and we have Blastoise. Actually, we've already kind of explored their similarities. Let's say Venusaur and I don't know how to pronounce that. Hatterin. Alright, so we're going to start with a Pokemon. We're going to start with Venusaur. And then we're going to go to this Pokemon called Hatterin. Alright, so we're going to show one shortest path. And then we're going to be able to go through any vertex and any edge. So we can go through anything to get to this one. So let's see. Alright, this is pretty cool. So Venusaur is a grass type, and so is this Pokemon, Tapu Bulu. And this Pokemon is a fairy type, and so is this Pokemon. So that's the shortest path to go through this. And so with Graph Studio, you can explore things like finding the shortest path. How are these 2 Pokemon closest related? So that's pretty cool. Is everyone, okay, cool. All right. What we're going to work on next is we're going to edit our schema and add more data into it. So this is a schema change job. I'm not going to go too in depth about it yet, but what we're doing in essence is we're going to change our vertex. So a Pokemon is more than just its name, right? It has other characteristics. Here we're going to add other attributes, other characteristics to our Pokemon. So we're going to add 3 more. One's going to be image. So while we can't add the image of the Pokemon itself, it's just going to be a URL to a picture of the Pokemon. Then we're going to add the weight. And finally, we're going to add the height of the Pokemon. And these are both going to be integers, weight, and height. I'm not quite sure what unit they use for Pokemon. I'm just going to call it units. And then the string is going to be, the image is going to be a string. It's just a URL. So we do that. This is going to be global. And then this one, the drop, it's just because if you want to run it over and over again, it won't like you to create like duplicates. So you have to say, all right, I'm going to delete this if it already exists. And then I'm going to create this. All we're doing here is just altering the Pokemon vertex. We're adding attributes. So you could add or drop. Drop would be delete. So we're going to add attributes, and these are the attributes we're adding. Next, we're going to run this schema change job. We'll just run it, and then we will see it working. So for context, if we can get here fast enough, don't think so, but if you recall, so here. Now, at first we only had the name, which is string underneath it. Now we have image, which is also a string, weight, which is an integer, and height, which is an integer. So we have everything here in the vertex as attributes. Now we're going to add more vertices and edges. So as I mentioned before, we're going to add the ability vertex, and we're going to connect it to the Pokemon using a Pokemon ability edge. So we're going to do that. And then we're going to run this. So this one isn't a global schema change job. So you'll just be able to find it here in the Pokemon graph instead of on global view. Then, so right now we only have these 2 vertices. We refresh, reload. Now we have ability as well. And ability is connected with a Pokemon ability edge. All right. So now, like what we did last time, we're going to load the data. So we once again create this request. we're going to create a GET request. We're first upserting the Pokemon vertex. Then we're going to go into the types. We're going to upsert each type and an edge connecting those two. Then for the abilities, we're going to upsert ability vertex. So the ability is going to be the vertex type. Its primary ID is going to be ability name. Then attributes will be ability name. Then we're going to upsert an edge connecting the two, so connecting Pokemon with the ability. So Pokemon, then this is the unique ID for Pokemon, the species name. And then we're connecting it using a Pokemon ability edge. And ability is going to be the vertex we're going to. Then we're going to go to which ability vertex? Well, the ability name vertex. This whatever this value is. Just going back a bit. So for the attributes, we have once again what we had last time. So the name being this. We also have the image now to load, and that's just going to be the front default from the official artwork section. Then we're going to get the weight, which is going to be from the weight section. And lastly, the height, which will be just height. And then we can run it through. Okay, so we added Bulbasaur. We added Ivysaur. We added Venusaur. We added Charmander. We added Charmeleon. We added Charizard. We added Squirtle. We added Wardle. Yes, Blastoise. Okay. So now if we were to look for those Pokemon in our graph, so something else, I'm going to hide all of this. You can also look for a specific thing. So say I want to look for Squirtle. Search. Now you can see Squirtle is of type Pokemon. Its height is 5. Its image is the URL. Its name is Squirtle, and its weight is 90. Something else you might want to notice, which is just kind of cool, is that if you look at any other Pokemon, which is not one of the ones which you just upserted, everything will default to either 0 or blank, like Gengar. So its height is 0, its weight is 0, that'll be like the default, and its image is just kind of like an empty string. But we can change that by adding all the data. So once again, I created a CSV of all the API data. And this is going to be the head. And then we're going to upsert just all the data into our graph to explore. All right, everything's uploaded. Oh, and then just one small little vocab thing. So upsert is what you say to, like, you upserted data to it. You added it to the graph. So you can think of it right now just as, yeah, I loaded data into the graph. Okay, so we have now 1,163 vertices. We have 2,409 edges, and then this is kind of the breakdown of all the edges and vertices we have. Now you can go explore this graph. I'm going to hide everything. So let's look at some Pokemon. Okay, Venusaur. You can double click on it. And now you see, along with the types, which are grass and poison, there are also abilities, such as chlorophyll and overgrow. Then you can continue clicking through here. And then these are all Pokemon which can use chlorophyll, like Sawsbuck. Click on that. But let's see what else it can use. So we can just keep on going on and on and on. We can explore what is the shortest path between these two Pokemon. Let's say instead of being able to go through type, we're just going to say you can only look through abilities. So there's the path. We go from there to Healer to Bellosome, then Chlorophyll and Venusaur. So that's another path it can take. You can maybe try with a different Pokemon, and we can just see both. Yeah, so here, undo this. Undo, find. So like in this example, we go from Hatteran to Anticipation, Toxicroak, Poison, and then Venusaur. So you can do all sorts of ways to get from one vertex to another. Alright, so next we're going to go through the basics of GSQL. Now that we have everything in our graph, the question is, how do we use that? How exactly do we use whatever we have in here to, I don't know, like create a dashboard, to get something meaningful out of it? That is using GSQL, which is a querying language. Now, GSQL might be a little bit confusing at first. It's unique for TigerGraph, and we're just going to kind of jump into it. So the first thing that we're going to do is we're going to run an interpreted query. There are two different types of queries. One is an interpreted query. The other one is an installed query. Interpreted query, you don't have to like install it and it's not saved, or it will be saved. You just don't have to install it. And then sometimes the performance can be not as nice, but for installed queries, you will have to actually load it into the graph and install it. And then you'll be able to get better performances, and then you can run it over and over again. You only have to install it once. We're just going to interpret everything because it does take a while to install some sections. I do believe later on we will install our queries because that just allows for more accurate performance. But for the introduction, we're just going to interpret it. All right. So starting from the top, interpret query. We're going to interpret this query. In these parentheses, you have parameters. We don't have any parameters in this case, so we're not going to worry about that. Then for graph, which graph is this query for? Pokemon graph, which is the graph we created right here. All right, so the first thing we're going to do is we're going to create a seed. Our seed is going to be called Catch Them All. So Catch Them All is just going to be Pokemon.star. What that means is that we're going to grab all the Pokemon vertices in our graph, and we're just going to assign it to this variable, Catch Them All. Then print Catch Them All. Okay, let's run this out. So here, what it did was it grabbed all the Pokemon vertices in our graph, and then just printed them out. And then we used the JSON library to print it out nicely. So here, we have Escalivier, and then it's a Pokemon vertex. Then we have the attributes, which is going to be a name. We can look at the image of this Pokemon. So that's what the Pokemon looks like. We have the weight, and we have the height. And this is all the Pokemon that we have. So we're going to get a little bit more complicated now. We're going to do a one-hop query. So we're going to create a query which starts at one vertex, goes over in an edge, and then ends up in another vertex. All right, so interpret query, once again, no parameters. We're using the graph Pokemon graph. All right, we start off with our seed. So we have all the Pokemon in this graph. Now we're going to create a variable called types. So this is using a select. I think it's more beneficial for me to start out with this from, and then we can kind of go back to the select. What you need to know from the select is that we're going to grab this thing called T. We don't know what T is yet. T is going to be from this section. So we're going to start off with catch them all, :S. What this means, catch them all is right here. It's going to be all the Pokemon vertices. And then we're going to refer to all the Pokemon vertices as S from now on. That's going to be its like code name. It's Elias. All right. Now these dashes right here means that it's going to be a undirected edge. So we don't have any directed edges, so you don't have to worry about that. Just keep with the dashes. Next, here we're going to go over the Pokemon type edge. So the Pokemon, it's called Pokemon type. Then we have the : and the Elias, the other name for it. Then we're going to end up at a type vertex, and the alias for that will be t. So kind of going here, we're going to start at Pokemon, we're going to go over the Pokemon type edge, then we're going to end up at t. And then that's what we're going to grab. We're going to grab all the t's. So this saying grab t, select t from the type. So those would be the types. We can run that. Then you can see here are all the different types of Pokemon. We have the grass type, we have fire type, we have all sorts of different types from there. All right, we're going to do one last layer of complexity to this. This is the same thing that we did before, right? We have the interpret query for Pokemon graph. We're going to catch them all. Then we're going to go start from the Pokemon vertex. We're going to go over the Pokemon type edge. Then we're going to end up at the type. Now we have this where clause. Now, this where clause it's like a filter. So we're saying where s.weight is greater than 500. Now what this says right here is that we're going to grab the s, which will be the Pokemon, and the s.weight is going to be the attribute. All right, so we have to have types where one of the Pokemon's weights, at least one of the Pokemon's weight, is greater than 5,000. You can run that, and then you can see, okay, the types which have at least one Pokemon which is heavier than 5,000 are poison, flying, steel, dragon, ice, ground, dark, psychic, ghost, and rock. All right, now this is just a bit of much more complicated query. What I want you guys to take away from this is accumulators. So there's different ways to accumulate over some value over a query. So this one's average accum, so you'd find the average of something. Here you have a sum accum, so it'd be the total, the sum of something. And then there are a bunch of different other things which you can do for GSQL. You can have that select and where clause, which we've used, and also there's the from. Then the accumulator is going to be how we're going to accumulate something. Then we'll have a post accum, which is kind of like an accumulator, or it's very similar to an accumulator, but it's just like another one, and you can use whatever you accumulated from the past one in your post accum. Having is like another where clause, but after you did your accumulators, and you have order by, which is just a way to list it out, and you have a limit. How many of these are you going to print out? So that's really complicated. Don't expect you all to know this yet, but if you're interested in like diving into them, there will be a course, as I mentioned, on this, where you can explore everything in much more depth. All right, now we're going to create our linear regression with this. So to do this, we're going to use Plotly Express. It's a way that we're going to be able to create nice visuals, nice graphs, pretty easily. All right, we're going to start off with a really simple query, which is going to be our catch them all query. The Pokemon star, the thing that we first started out with. And we're going to print that out. And then this just means that we're going to select the catch them all from the result. Next, what we're going to do is we're going to add them into these lists. Now we could do this through GSQL as well by using a set accumulator, but to keep things simple, we'll just do it in Python. And then lastly, we're going to put them into a data frame. So we're keeping the Pokemon's height, weight, types, names, and also symbols. Then here, we're going to create our linear regression. So it's just scatter. We're going to provide the data frame. So that's going to be the height and the weight data. Then we're going to add names for the axes. The hover name will be able to look at what exactly the name of Pokemon is. And then the trend line is just going to be the linear regression. All right, here's a little linear regression. So you can hover over things, as mentioned, and you can get the name of the Pokemon, the weight, and the height. Now, clearly, linear regression might not be the best thing for this. So if you click somewhere and you're able to drag, that's how you can zoom in. So you can see yeah, it might not be the best way to model this data. You can hover over your line and you can get the trend line, you can get this equation, and you can also get the R-squared. The R-squared is 41%, which is quite low. And yes, to unzoom, you can double click and you'll go back out to here. Let's see. These are some of the Pokemon which are pretty big outliers. Wow, this Pokemon has a height of 1 and a weight of 9.999k. That's impressive. So next we're going to create a query, kind of like what we did before. I'll walk you through this query. So this query will be for our Pokemon graph. Here, instead of catching all the Pokemon first, we're just going to grab all the types. Now we'll start from types, and we'll select the Pokemon where the types are the parameter. So say we pass in fire, then this will give us all the fire type Pokemon. This will take a little while to run because it'll try to create the query and then needs to install it. But here we just have the type.star, so we're going to grab all the types, then we're going to go from the type over the Pokemon type vertex or edge, then end off at the Pokemon vertex. And then the where, we're going to filter everything. We only want the ones where the type ID, where the type is ty, so whatever this input is, which is going to be a string. And as soon as we run it, then we can use that to create another linear regression, but just for certain types. So for here, for example, if we want certain types to be like just fire or just flying, then we can run that through here. Okay. So we'll wait for that to install. And then as soon as it's done, we're going to just run this. So here we have the, we're running the installed query. So the query name, I just called it grab. Then we're passing a parameter, which is ty, fire. So we're just going to grab all of the fire types. Lastly, we're going to do exactly what we did in the past. So put them out into lists and then run it. All right, so here's the fire types. It's a lot better looking than all the types. And then if you want to do flying, here are all the flying types. Okay. So lastly, we're going to create a dashboard with all of this. So here we're going to install all of our dependencies, Jupyter Dash, core components, HTML components, and then some graphical objects. We're going to run, create a query. And then here in this query, we're going to grab the type count. So how many Pokemon are there per type? Okay. So we're going to wait for that to install. So what it does here, we have an accumulator, which we mentioned before. An accumulator is a sum-accum. It's going to be able to count up how many of each Pokemon we have. So now we're going to run it, and we're going to put it into lists. And then lastly, here we're going to be able to create our final graph, or a final dashboard using Plotly Dash. So we'll be able to just run it in mode external. So here we can go ahead and click onto this, and we'll open up Pokemon Dashboard Demo. And then we have a bar chart with all the counts. So you can see like we have a lot of water types, but we might not have as many ice types. And then here is the the linear regression, which we created back here. So we can go ahead and explore this. We can explore this dashboard. You can once again drag if you want to look closely at it. You can hover over it to be able to see the count and that. And then eventually we can work on getting more complex, more features onto it. So like if we click onto it, we can look at more details about the Pokemon. We can have it show here in the linear regression and so on. So congratulations, you've created your first ever graph with TigerGraph. You created your solution. In this lesson, you learned how to create a schema and upsert data into your graph. And then you learned some GSQL, and you were able to create a dashboard with TigerGraph. So if you do want to explore more about TigerGraph, there is a developers portal where they have a bunch of cool tools in the ecosystem, a bunch of projects you can explore as well. And finally, we have, if you want to like redo this all together, you might want to just drop everything in your graph. So this is like a dangerous command where you can like data snap everything out of existence. Well, all of your graph out of existence. This would just be a drop all for that. So thank you all for coming. And then if you do have any questions, please let me know. Oh, there are questions in here. Okay, what coding language is your favorite? I have to say Python, because that's what I'm using right now. And yeah, it's pretty cool. And then was math my favorite subject? It was indeed. All right, so check out TigerGraph, and if you want to learn more, I will repost this notebook into the chat if anyone wants to just look through that again. And if you have any questions, oh, I've already sent this message. I apparently can't repost this in the chat. Here, notebook. All right. So if you want to look at that lab again, if you want to take it at your own speed, feel free to do so. Thank you very much for coming, and have a great rest of the time at the conference. Oh, wait, there's more. Okay. Your Graph Studio will not work. So if you do need help debugging that, I can help you out. What exactly is not working about your Graph Studio? Are you not able to open it up, or are there like certain features that aren't working? And then for Derek, how long have I been coding? I apologize about the phone. I've been coding for about almost 5 years now, which is cool. Okay. All right, see you guys later. I hope you have a fantastic time at the conference, and have a great rest of your day. Oh, user authentication fail. Okay. I think that would primarily be because you entered the wrong credentials. Hold on. Let me see. I know I'm going over time, but let me share the entire screen. All right. So when you start this up, sometimes you probably encountered a login page. I'm unsure if you did, let me know. And then there you need to enter in your credentials. So it's whatever you entered in when we first started, which was in here in setting up your TigerGraph box. So you need to use the exact credentials used here. I believe your username will be TigerGraph by default, and then your password would be this. So I'd recommend maybe terminating your graph and then restarting it, and just keep the initial password as is, and then see if that works. Because I don't recall, or I'm not completely sure what your credentials were. So just keeping everything with the default might be the best go for you. I hope that helped. Let me know if you have any problems. And then, as Sean said, you can reach out to me. If you need to connect with me, you can send a message to devrelations@tigergraph.com, and I can walk you through any problems that you might be having.